Yes, good afternoon everyone. This is Dr. Santosh Kumar. Myself, I am having 18 years of experience. My specializations are antennas, electromagnetics and all those things. I have published almost 40 plus papers in international journals as well as conferences, and I have published 6 textbooks with 4 patents. Okay, so now my topic is Maxwell equations. So now, first, before going to the Maxwell equations, first we will discuss what is the need of these Maxwell equations. What is the need of these Maxwell equations is nothing but here all the communication systems, whatever the communication systems we are using till now, that is either cellular mobile or else wireless or else radar or else whatever the type of communication systems right now we are using, all those communication systems are using the electromagnetic waves. So how the information is passing means, for example, I am speaking, so how this voice is reached to another person, so that is in the form of electromagnetic waves. So now all the information, all the communication systems are using electromagnetic waves only. So now those electromagnetic waves, how we can define those electromagnetic waves will be depends on this Maxwell equations. So the world of electromagnetic are decided by these Maxwell equations. So basically we are having 4 Maxwell equations. So within that 4 Maxwell equations, 2 equations for the electric field as well as 2 equations for the magnetic field. Basically we are saying that electromagnetic wave, that is EM wave. Okay, so electromagnetic wave, so means in this case we are having an electric concept as well as magnetic concept. So for the electric we are having 2 Maxwell equations, as well as for magnetic we are having 2 Maxwell equations. Okay, so total we will have 4 Maxwell equations. So first we will discuss those 4 Maxwell equations. So first Maxwell equation is del dot D is equals to rho V. Second Maxwell equation is del cross E is equals to 0. Third Maxwell equation is del dot B is equals to 0. Fourth Maxwell equation is del cross H is equals to J. So these are the 4 basic Maxwell equations, that is 2 Maxwell equations for the electric field, these 2 are for the electric field and these 2 are for the magnetic field. So now see here in the electric field we are having this D is nothing but that is the electric flux density and volume charge density, and E is nothing but electric field intensity. In the similar way of these 2, we are having 2 more equations for the magnetic field. So whatever the electric is this one and whatever the magnetic is this one. So these 2 equations will come from the magnetic field concepts and these 2 comes from the electric concepts. So within this magnetic case we are having del dot B is equals to 0, del cross H is equals to J. So now where B is nothing but that is magnetic flux density, this is the electric flux density, both are similar. Okay, so now H is nothing but that is a magnetic field intensity. So these are the 4 Maxwell equations basically we are having. So based on these 4 Maxwell equations we can generate number of Maxwell equations for different fields. Why? Because we are transferring some information from one point to another point, means that will be different mediums. Somewhere it is a free space, somewhere it is a dielectric mediums. So we are speaking, that is nothing but our voice must be reached to the destination or else to the receiver person, means all the surface, all the atmospheres must be satisfied. So for that case we are defining all these 4 Maxwell equations in different fields. So like for a free space, for a conducting medium, for a good dielectrics, for a harmonically varying fields, for different fields we will define these 4 Maxwell equations. So first we are having del dot D is equals to rho V. So how we are deriving this del dot D is equals to rho V? So that is based on the concept of Gauss law. Okay, so now how we are deriving this del cross E is equals to 0? That is from the potential concept, that is electric potential. And next third one, del dot B is equals to 0. This is from the concept of magnetic field or else magnetic flux. Okay, so now magnetic flux. and next last one, that is del cross H is equals to J. How we are deriving this one is by using a Ampere's law. Okay, so now these are the 4 equations. How we are deriving these 4 equations are this one. So now Gauss law, potential as well as magnetic flux, and last one is Ampere's law. So now see here, if you observe these 4 equations, these 4 are nothing but these are the static. Okay, these are the static Maxwell equations. Static Maxwell equations is nothing but, that is nothing but all these Maxwell equations, these 4 Maxwell equations does not depend on any time. Okay, so means see here, if you observe these 4 Maxwell equations are not having any time factor. Is it right? So generally EM wave. So what do you mean by wave? Wave is nothing but it is a signal which carries some information. With respect of time. Okay, so with respect of time means if the time changes, whatever the information is also changes. For example, I am speaking. So now I am speaking about the first Maxwell equation. At this particular time, so and so we are speaking about first equation, and after some time we are speaking about second equation. Means time changes and whatever the information is also changes here now. So now with respect to of time, whatever the information is changes. So now see here, if you observe these 4 Maxwell equations are only for static, that is nothing but we are not discussing about the time factor. So now we need to have a time factor Maxwell equation, that is a time varying Maxwell equation. These are called as time invariant Maxwell equations or static. Okay, so now coming to the time varying Maxwell equations. Time varying Maxwell equations here in the similar way, time varying Maxwell. Okay, time varying Maxwell equation. So now time varying Maxwell equations, here also we are having same 4, whatever the 4 we have discussed till now. So these 4 will be in terms of time. With respect to of time, we are defining these 4. Okay, so within that, first one is del dot D is equals to rho v as it is, and second one is del cross E is equals to minus dou B by dou T. Third one is del dot B is equals to 0. Fourth one is del cross H is equals to J plus dou D by dou T, or else it is also treated as JC plus JD. Okay, so now these are the 4 Maxwell equations which is derived from these 4 Maxwell equations only. Okay, so now see here we have it out. Here we are having 4 Maxwell equations, but within these 4 Maxwell equations, second and fourth equations are having time factor, and what about the first and third equations are not having any time factor. So it is not having any time factor means here we have a relation between D as well as E. For example, see here it is del cross E is equals to dou B by dou T. This del cross E, whatever the left side value, that is E value, electric field intensity, will depends on the time factor. We know this one. So now whether if electric field is depends on time factor. Okay, we have a relation that is D is equals to epsilon with E. Okay, means if this electric field is changes with respect to of time, this electric field changes, then definitely whatever the flux density is also changes. So that is nothing, that's why this is also a time varying field. So now in the similar way, here also we are having del cross H is equals to J plus dou D by dou T. So dou D by dou T is nothing but here magnetic field intensity is changes with respect to of time. Here also the magnetic field will be changes with respect to of time. So now H is changes with respect to of time. So we have a relation that is B is equals to mu with H. B is equals to mu with H. So now if H is depends on a time, definitely B is also depends on a time. So finally this is depends on time, this is depends on time, this is depends on time, this is depends on time. These 4 are the Maxwell equations for time varying fields. Means if the time changes with respect to of time, whatever the information is also changes. So these are the time invariant Maxwell equations, these are the time invariant Maxwell equations, these are the time varying Maxwell equations. This is just an whatever the introduction for the Maxwell equations. Just we have discussed time invariant as well as time varying Maxwell equations. Okay.